Assalamu alaikum. My name is Tabassum Tahira and my group mates are Muhammad Alamin Ashik, Shariful Islam, Ali Muhammad Tarif and Asir Faisal. So our project title is Self-Driving Car Simulation using ACNN or adaboost CNN. So what we have done in our project, first we set up the environment for the simulation of self-driving car. For training, we adapted an ensemble learning algorithm, namely adaboost, with convolutional neural network. For training, we use 80% of data, and for testing, we use 20% of our data. After getting the result, we compared the outcome with normal simulation using CNN. So how we have done our project is we used adaboost classifier with the ability for rapid classification is used to complete the car training. And then we obtain the simulator developed by Udacity for the self-driving. Previously it was only for Udacity courses, but they made it open sourced. Okay, so that's all from me for ACNN. Will be further explained by my another group mate, Shariful Islam. Thank you.
Assalamu alaikum. This is Shariful Islam, and today I'll talk about what is adaboost CNN. And adaboost CNN is a variant of adaboost boosting algorithms, and as a base classifier with adaboost, we can easily adopt a few weak algorithms like k-means clustering, decision trees, naive Bayes, and so on. But for our project, we will adopt CNN with adaboost, so it is much more difficult. To adopt adaboost with CNN, we divided our training set into two phases. One is pre-training phase, the another one is post-training phase. To do pre-training phase, we take three CNN models with our adaboost, and we take a few words to train our three CNN models. And after training few times, when we get the error rate less than 0.5%, we stopped our training and saved the trained model. So after after doing the pre-training phase, we go for post-training phase. In post-training phase, we can easily understand the difference between adaboost and adaboost CNN. In adaboost, we take one input image and three CNN models, and in three CNN models, we use different weight to train our adaboost models, and after that we give them booting power. If the CNN one model gives more than 90% accurate results, and the rest to give the less than 20% accurate results, then if we give any image and the as a CNN one algorithm gives the accurate give the results, that will be our final results, just because of the booting power. In adaboost CNN, we update for the input 5, we have 10 different weight classes like 0 to 9. So we multiply weight classes with our CNN weight, and after that we get the for these three CNN models, we use 30 different class weights, and we trained our model like this. After training this, we give them the voting power. If that time also the CNN 3 give the more than 90% accurate results, and the CNN 1 and 2 give the less than 20% accurate results, then with the with the voting power, we will choose whatever results give from CNN 3, and we'll get our final results.
Okay, Assalamu alaikum warahmatullahi wabarakatuh. I'm Md.Asir and I'm going to start with the ACNN flowchart here. So basically, what is the CNN flowchart is actually the flowchart that describes how the algorithm is functioning. So here we start from the SLC. SLC is sample learning coefficient. So we input images, maybe 10 images or 100 images or 1000 images. So each of these images has the weight. So if there is 10 images, each of the images weight is going to be 1 by 10. If there is 1000 images, the weight of the each image is going to be 1 by 1000. So the images has been given as the input, and then we have the CNN, which has been already created in the pre-training phase. The CNN has been created before in the pre-training phase, and all of this CNN error rate is less than 0.5, so they are pretty accurate. So moving on to the BCW is base classifier weight. The BCW is the system that calculates the weight of the CNN1, CNN2 and CNN3 and CNN4. So which basically means that the BCW defines which will be the most accurate CNN. For suppose if CNN1 is very accurate while turning right, CNN2 might be accurate in acceleration, or else CNN3 can be accurate in braking. So like this, BCW determines their weight when there is an voting for the CNN output. Now CNN output is like they calculate the gradient, which is the voting power, and assign to each CNN. Now after this, an epoch is finished in this process, and when an epoch is finished, we change the image. And when you input a new image, when there is a input a new image, this tests the CNN1, CNN2, CNN3 and CNN4. So this testing is something like determining the accuracy of the CNN that we are going to include in the algorithm. So the CNN1, CNN2 or CNN2, the test for the accuracy is done, and if the error rate of CNN1 is the least, the voting power of the CNN1 becomes the highest. So if the error rate is inverse to the voting power is BCW. So like this, who has the least error, the he or she, this CNN gets the most voting power. Like this, after we are done, the iteration is over and we input new SLC, and this is been done until we are in reaching the end of our data. So now moving on to the next part is our CNN model. Is something that is very simple. We include the image with 5x5 convolution, filter is 24, strides 2x2, and the activation LU. So when there's a lot of image input, the neuron drops out 50% of neuron, which is fully connected with the activation LU. And when we are done with this, then we have our desired output in the neuron, and we make sure that the image that has been the most efficient is used as our output, as our data set, which can be trained for the upcoming algorithm we are using here. That's it all for me. Thank you very much.
Assalamu alaikum, I'm Ali Muhammad Tarif, and now I would like to explain about how to train our model, which is ACNN. And at the very first, we focused on 4 levels, which are left angle, right angle, speed, and brake. Here you can see this is a picture, but this is the actually video games. For collection of data purpose, we played this game for various times and the one thing is that there are three cameras. Three cameras is mounted in the car, which is left corner, right corner, and the center corner. While we played this car, or while we drive this car, the camera is capture image simultaneously with the corresponding level which I already mentioned, so that is left corner, left angle, right angle, and speed and brake. Okay, after finishing to play this game, finishing to play these games, those picture those picture who are actually obtained from the camera is automatically stored with the corresponding level. After collection of data, we go through our model to train our model. Okay, that's it. Mm, okay, now this is the testing section, and now I would like to tell the car how the car actually drive itself. Okay, now this is the video game sections, and this is our model server. While the car drive by itself, the camera capture the image and send to the our model, and our model our model uh, our model gives us the best accuracy, which you can say which you can see. This is the -3 uh, -3 angle, right rotations, and now this is the brake, this is the braking system, and this is the distance which we already see the picture. You can see this is the brake, which is the same as our model, same as, and this is the angle which is the same as our model. So it's always gives us the best accuracy as much as possible, as soon as possible. Now we go through the conclusions. As a driving car is very sensitive to each input. There are four, we have the four input we already mentioned, which is left angle, right angle, speed, and brake. If any one input is if any one input has a low accuracy, that it will be effect on the other input. So our model gives us the final accuracy, and um, and take care the full input accuracy as well, and for further work, ACCN we can be used to detect other vehicle, human, and traffic. That's all. Thank you. Assalamu alaikum.
Okay, starting track 1. Okay, so let's go with the training mode. Okay, training mode means the autonomous mode, so the car will drive itself. So we have two track to train and test. Okay, so we have been selecting the first track, and let's go with the autonomous mode. So for now, the autonomous mode, I mean the car is sending current images to server, and the server, I mean this is the server, so the server is responding with corresponding key to be pressed. That means the angle and speed, expected speed, and it will define the throttle, I mean the acceleration itself. Okay, so on left we are having three things, that is angle, corresponding angle, then acceleration, and then current speed. Alright, so we see that the car is like almost driving accurately. So it's like it depends on the number of hours we have trained and number of the data. So for DGB wasn't enough, because latestly, I mean, Udacity trained with 120 above GB data, so to get more accuracy, yeah, so we can record this part as well. Alright, so it's like car is driving kind of smooth almost now, because once it's balanced, so it's easy for to continue. But yeah, but when it's getting I mean turning, so it's not that smooth. But yeah, I'm well enough to go. Alright, so it's about to finish one lap. Okay, so it's almost about to finish. Okay, so on this place MPS we're having the current speed meter per second hour, and then we're having current desired angle, I mean what angle being responded by the server, and the mode is autonomous. Alright, so we're not recording anyone, but yeah, so it's finished one lap. Alright, so that's the end. I mean we can take over